All right, so today will be, yes?
I finished it.
Pardon?
I finished the homework.
Okay, not right now, thank you. So today we're going to be doing something called solving triangles, which is where you'll be given some information about a right triangle and asked to find all of the other sides that you don't know and all of the angles that you don't know. Okay? So some of it will involve trigonometry, some of it will not. Some of it will be stuff that you learned earlier this year, or actually you did again for the second time because you actually learned it in like 7th grade. So we start with an idea that's really important to what we're going to be doing today. And that is this: if the square root of x is equal to 7, we would find the value of x by squaring both sides. Now, why would we square both sides? Yeah, get rid of the square root because squaring and square roots are inverses. Some people say opposites. Inverse is the correct term. Can somebody give me another thing in math that are inverses of each other?
Plus and minus.
Yeah, subtraction.
Okay, adding a number and then subtracting that same number. Yes? Yes?
In perpendicular lines, the slopes are inverses of each other.
I don't know that I would call them inverses, but yeah, I see what you're saying. Yes.
Multiplying and dividing.
Yeah, multiplying by and dividing by the same number. Yes.
In chemistry, if the pressure goes up, the volume goes down, and vice versa.
Because PV is equal to nRT, right?
We would test on that today.
Pressure times volume is equal
The
to
number of moles times
Are
the
you
universal
arguing
gas
chemistry?
constant times temperature.
temperature. And is temperature in degrees C?
Kelvin.
It's in kelvins.
Are you arguing chemistry too?
Pardon?
Are you arguing chemistry too? Potentially.
No, it's been too long since I've taken chemistry. I remember bits and pieces. All right. So if you want to expand it to that kind of idea, you can do economics like supply and demand. When right, if there is an overabundance of supply, the prices tend to go down. Whereas if it's the other way around, the prices tend to go up, which is why some gaming companies artificially keep the supply low. Yeah. That way they can charge a lot of money for it. Okay. All right. So every trig function also has an inverse. The inverse of sine is called sine inverse, or you can say inverse sine. I don't care which way you say it. Sine inverse, inverse sine. Please do not say that sine with the -1 thingy. Okay? Because that is how it's written. It's written a sine with a -1 like it's an exponent. That is the symbol for sine inverse. But if you say sine with that -1 thingy, you risk having me make fun of you. Why are you laughing at that?
Calling me out. Dang. I feel like that was like a direct attack. Yeah, like a pet peeve.
It wasn't aimed at anyone in particular. It's just aimed at anyone who uses it. And you've never had the opportunity to say it wrong before now, so you're gonna get it. Wow. All right. So what do we use this for? We use it for finding angles in a right triangle using trigonometry. Let me show you how this will work. So here, find the measure of each angle to the nearest 1/10 of a degree. All right, so the angle we're trying to find is x here. From x, what are the two sides that we have?
Adjacent.
The opposite and the adjacent.
We have opposite and adjacent. So what do we have to use?
Inverse.
Tangent. Just tangent. We are going to set these up and then solve. So we're going to start with the equation just like we've been doing. It'll be the tangent of x is equal to 67 over 43. Then we want to get rid of the tangent, just like we wanted to get rid of the square root in that earlier problem where we had the square root of x was equal to 7. So we got rid of it by doing the inverse. We'll do the same thing here. We'll end up with x because the tangent inverse and tangent undo one another is equal to the tangent inverse. Everybody say it. Tangent inverse. Say it again. Tangent inverse of 67 over 43. And at that point, you just grab your calculator and go, okay. First of all, I have to wake mine up and tell it to stop doing statistics. God bless you. If you have a TI calculator, the tangent inverse is right above the tangent in blue, which means you need to hit the second button before you hit tangent. So if you do second tangent, it will do tangent inverse of 67 over 43. And it said to round that to the nearest tenth of a degree. So to the nearest tenth, this is 57.3 degrees. Okay, any questions about that? So this is a new use of trigonometry for us, where we can turn it around and use and find angles instead of finding sides. Let's take a look at this next one. From x, which side is 95? Hypotenuse, and 28 is? Adjacent. So which ratio are we going to use? Cosine. Cosine of x is equal to the adjacent, which is 28, over the hypotenuse, which is 95. So then we want to get rid of the cosine. So what will we use? Cosine inverse. X will be equal to the cosine inverse of 28 over 95. So second cosine to get the cosine inverse, 28 over 95. And we get that x is approximately 72.9 degrees. Okay, any questions about that? All right, well, see if you can set up the last one on your own. At the very least, set it up. Hopefully, be able to solve it. All right, Braden, do you have it set up? I'm sorry? Oh, no, just the equation. So I need an equation. Something equals something. We don't ever start, we've never started with an inverse. Start with either sine or cosine or tangent. So from the x, which side is the 86? No, adjacent is the leg. So this is the hypotenuse, right? And this is opposite. So which one of our trig ratios has both of those in it? Sorry, it's opposite and hypotenuse. My fault. Opposite and hypotenuse, not adjacent and hypotenuse. Tangent's opposite over adjacent. So you need to do a little work on memorizing. I understand, but it's still early in the unit. I'm not unhappy that you don't have it memorized yet, but you need to get a little bit better. So remember that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So which one of those is it?
It's the sine.
Right. So we're going to have sine of x is equal to 75 over 86. Travis, what will we do now?
Would be x equals inverse of sine times 75 over 86.
All right, just one thing. It's not inverse of sine times.
Oh.
It's the sine inverse of this. Just like if you see on your calculator, it's doing like the square root of something, and it's the square root of 75. What is it that we're taking the square root of? The sine inverse is an operation. It's not a number all to itself. Okay? Did you go ahead and put this in?
Mine said error. I don't know why.
You're probably not in degree mode, but even if you weren't, let's see. So go to the mode. Okay, it's in degrees. Quit out of that. Oh, what
No,
did you
I
put on?
just 75.
So you got it now?
Yeah, 60.7.
Do I have some agreement? Yes?
Mhm.
Thank you. Yeah, one thing to point out here, he accidentally put 86 over 75. You can't take the sign of a number that's bigger than 1.
You mean the sine inverse?
Pardon?
You mean the sine inverse or the sine?
Yeah, you can't. Sorry, my fault. You can't take the sine inverse of a number that's bigger than 1. And the same thing is true for cosine, but not for tangent. So if you ever get an error, don't bring it to me and tell me my calculator's broken. It's not the calculator. Okay? All right. Any other questions about this one? All right. Let's go on to page 2 then. And I'm going to change this one. I'm going to tell you that this side is 12 instead of telling you that that side is 5. Doesn't change it a lot. It changes a little. Okay, so the instructions say find the missing measures, round lengths to the nearest hundredth and angles to the nearest degree. Again, this is called solving a triangle. You find all the things that are missing. Yes?
How do you know whether the leg that we're given is adjacent or the opposite?
Okay, so if you're talking about angle R, 7.5 would be adjacent because it's one of the sides of angle R, as opposed to ST would be the opposite because it's all the way across the triangle from it. That make sense?
Well, how do you know which angle we're talking about?
Well, in the problems that we've done before now, you were always given one of the acute angles. So that's the angle you're talking about. Here, we're going to, pick one of them and find it. Okay? All right, notice on this, we were given 2 out of the 3 sides, right? I personally always start with what I'm given 2 out of the 3 of. You're always going to either have 2 out of the 3 angles, or you're going to have 2 out of the 3 sides. That's the minimum requirements for these problems. So, how can we find the length of ST? Yeah, we're going to use Pythagorean Theorem. So we're going to have 7.5 squared plus ST squared is equal to 12 squared. I will say one of the things that some of you are going to like a lot about this is we're not going to try and simplify square roots on these because a lot of times they're not whole numbers. Okay? It says give lengths to the nearest hundredth. So we're going to use our calculator for this. So I'm not going to find out what 7.5 squared is, although it is, wait a minute, 56.25? I know a trick for that one. There's no point in it. What I am going to do is subtract 7.5 squared from both sides. And I get that ST squared is 12 squared minus 7.5 squared. And I'm still not going to pick up my calculator because I don't have ST by itself yet. How do I get ST by itself now? Take the square root. So ST will be the square root of 12 squared minus 7.5 squared. Once I get the algebra done, then I'll grab a calculator and go, okay, what is that approximately? So the square root of 12 squared minus 7.5 squared. So ST to the nearest hundredth is 9.37. All right, everybody good with that? That's just Pythagorean theorem. So now let's go about finding the angles. Doesn't matter which of the acute angles you find first. Let's say we decided to find R. So if I'm looking for R, let me just say, for 2 reasons, you should not use the 9.37 to help you find R. The first reason is, that's an approximation. You have rounded the answer off. Sometimes when you round something and then use it and then round it again, you don't get the right answer quite. You get close, but you don't quite get the right answer. The second reason is, what if you accidentally somehow messed up in finding it? You accidentally typed in 6.5 squared instead of 7.5 squared, and it's the wrong number. Is there any way you can get the right answer? No. So don't use a calculated value to help you calculate a new value if you can help it. I know that in science a lot of times you have to. You calculate this and then you use that to find this, and you have to do significant digits and all that. In math, we don't do significant digits, and I had a science teacher argue with me about that once, and I said, well, in math we just assume that when I tell you that something is 12 centimeters, that it's exactly 12 centimeters to an infinite number of decimal places. They're like, that's crazy, you can't do that. I was like, I just did. So, all right, so let's find R. So from R, what side is 12? Hypotenuse, and 7.5 is? Adjacent. So which one of the ratios has hypotenuse and adjacent in it? Cosine. So the cosine of the angle at R is going to be equal to 7.5 over 12. And then algebraically, how do we get r by itself?
The inverse cosine.
Yeah, take the inverse cosine of both sides. So r will be equal to the cosine inverse of 7.5 over 12. So again, second cosine, 7.5 divided by 12. So the measure of angle R, it said to the nearest degree, so that's the nearest whole number, so it's about 51 degrees.
Do we have to do like what we just did for the other angle, or just minus that the angle we just got from?
We can just subtract it from 90, because if you have rounded something and you add or subtract it to a whole number, then your rounding is still good. If you multiply it or divide it or do anything else, your rounding is off. Okay? So you're exactly right. We can just go, oh, I'll just take 90 minus that. And if you don't like it, well, you can just do this. You're like, I don't want to use 51 because that's a rounded number. Okay. Type 90 minus. And again, if you have a TI, if you do second, the negative sign, it takes 90 minus the previous answer. And you don't have to write out any of the decimal places. When you round that to the nearest whole number, we get the measure of angle S is 39 degrees. You could have just done 90 minus 51. It's going to work out the same way. Yeah, if you round and then add or subtract, you don't get round off error. If you round and then multiply, divide, square, pretty much anything else, you get round off error. Now, how severe it is depends. Okay, let's do this one. Notice that for this one, we're given two angles, right? So I'm going to go ahead and find the other angle. It's pretty easy. If I just do 90 minus 58, remember the acute angles add up to 90 in a right triangle. This is 32 degrees. And since that's an exact value, if you want to use 32 as your angle, you can. There's nothing wrong with it. I typically don't, because if I made a mistake, and I make lots, if I made a mistake, then everything else after that is going to be wrong if I base it on a wrong angle for C. So let's say we're going to find AB. So what side is AB relative to the 58? Anyone? Adjacent, exactly right. And the 14 that we're given is? Opposite. So what are we going to use to find AB? Tangent. So the tangent of 58 is equal to 14 over AB. Remember that we typically just put this over 1 and cross multiply, and we get AB times the tangent of 58 is equal to 14. How do we solve that for AB?
Divide both sides by tangent.
Exactly. Divide both sides by the tangent of 58. Thank you, sir. So we've got 14 divided by the tangent of 58. And we have 8 point, what did it say to round this to? Hundredth? Thank you. 8.75. Could we at least in theory do the Pythagorean theorem at this point? Yes. But since this is a rounded answer and you're going to have to square it, you're likely to get round off error if you do. So I would do trigonometry again to find BC. So BC is the hypotenuse and 14 is still the opposite. So which trig function is that then? Hypotenuse and opposite?
Oh,
It's sine. So the sine of 58 is equal to 14 over BC. Put this over 1 and cross multiply. We get BC times the sine of 58 is equal to 14. We'll divide both sides by the sine of 58. Pardon? Did I say multiply? Sorry. I meant to divide. So this would be 14 divided by the sine of 58. And that comes out to be 16.51. If you remember, on Wednesday, I said you should look at your numbers at the end to make sure they make sense. The hypotenuse had better be the biggest side. And the side across from the smallest angle should be the smallest side. So we know even if our answers are wrong, they're not crazy wrong. Okay? One other thing on your calculator real quick. Let me just show you a neat little trick that you may never have learned. So you know how here we had 14 divided by the tangent of 58? And we got an answer. And the next one, it's 14 divided by the sine of 58, which is almost exactly the same. It's just sine instead of tangent. You can save a little bit of time by going second, enter, and it'll pop back up what you typed in for the previous line. And you can just arrow back and change that to sine. It's not super helpful on this because it's not a whole lot less keystrokes, but especially as you get into higher math, if you type in something that's really big and ugly and you accidentally hit plus instead of minus and you're like, oh, I need to go back and fix that. I don't want to type it all in again. You can hit second enter, arrow back to whichever thing you need to change, and you can change it, which is pretty nice. All right, one last problem. One of the other things that we can do is we can do problems on a coordinate plane. So the coordinates of the vertices of triangle RST are R is at negative 3, 5, S is at 4, 5, and T is at 4, negative 6. Find the side lengths to the nearest hundredth and the angle measures to the nearest degree. Okay. So R is at negative 3, 5. S is at 4, 5. And T is at 4, negative 6. These will always be right triangles, and because I'm a nice guy, one of them will always be horizontal and one side will always be vertical. I could give you one where it's a right triangle, but it's like, turned sideways or something. The reason that having one horizontal and one vertical makes it nice is you can just count the lengths of those sides. This side is 1, 2, 3, 4, 5, 6, 7. So RS equals 7. And then this side is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So ST is 11. And just like in the last one, once I get two sides, I go ahead and find the third side. So I'll do the Pythagorean Theorem to find the length of RT. It'll be 7 squared plus 11 squared gives us RT squared. Take the square root of both sides. So I can get RT by itself. And then at that point, just grab the calculator and go, okay, what is the square root of 7 squared plus 11 squared? And it's approximately 13 point, it said to the nearest what? Hundredth? So 0.04. So RT, was it 13?
Yeah.
13.04. So I've got the sides now. Now let's find the angles. So from R, again, I don't want to use the 13.04 because what if it's wrong? And it's a rounded value. It's a bad idea to use it to find something else. So let's use the 7 and the 11. Relative to the R, what side is 7? Adjacent, and 11 is?
Opposite.
Opposite, so that means
Tangent.
tangent. So the tangent of R is 11 over 7. How do we get rid of the tangent? Take the tangent inverse of both sides. Once you have solved, you're ready to pick up your calculator. So second tangent of 11 over 7. It said round to the nearest degree, I believe. So 58 degrees. And then the measure of angle T, we can just take 90 minus 58, it's 32 degrees. Okay. Let me get that closed.